Hello. On behalf of my name is Sasson Qureshi, and on behalf of Team 3 and my group members Leah Barna, Amanda Houston, Fiona Lightfoot, Ella Ozdemir, and Sean Dowell, I will be presenting our regression analysis for Team 3. We use both Excel and AI to study the relationship, compare outputs, and see how useful regression is for estimating housing prices, with the main idea to see whether bigger homes tend to cost more and how reliably we can model that. The goal of this investigation was to determine the relationship between a home's square footage and its price. We found this important because if size strongly affects price, we can use that relationship to build a pricing model. For our data, this slide explains the real-world context of data. A real estate agency wants to understand how home size affects listing price in a changing housing market. The challenge is that pricing is not always straightforward, so the agency needs a more data-based strategy. Moving to our 5-number summary, here we compared it using both Excel on top, AI on bottom. Both approaches were looking at the same thing, the minimum, the first quartile, median, third quartile, and maximum. The similarity is that both help us understand the spread and center of home sizes, and the importance is that this gives us a quick picture of the distribution before we move it deeper into statistical analysis. For variability analysis, both Excel and AI show that the prices are fairly spread out, which suggests that there is meaningful variation, and the main similarity is that both recognize the price is not constant, even when homes are somewhat similar in size. Now, this matters due to variability helping us show whether size alone is enough or whether other variables could also affect the price. Now, for our scatter plot, just helps show the relationship visually. In both the Excel and the AI breakdown, the points move up overall, showing the positive relationship between square footage and price. So main takeaway from the scatter plot alone is that home size increases, price generally increases. Looking into our outliers, both Excel and AI help identify that homes may not fit general trend, even if they're not extreme enough to fully remove. So we're looking for unusual values using methods like IQR and residual analysis. The difference here in this example is that Excel gives the calculations directly, while our AI analysis tends to explain the meaning more clearly. We find this important just due to outliers that can pull the regression line and reduce accuracy. It's a little bit better to see those visually as opposed to having to verbally explain them. For our correlation matrix, this was measuring the strength of the relationship numerically. In Excel and AI, they both show that positive correlation of 0.927. Which means that larger homes tend to have higher prices, also reflected in the visual correlation matrix in the bottom right-hand corner, color-coded. The green color of the square foot and price block is very similar to the square foot, price block. So we can confirm that what we already saw in the scatter plot, and move forward with the regression and fit analysis. This slide just shows our equation of price hat equaling 74.826 plus 0.1477 times a square footage value, and our R-squared value of 0.859. This allows us to understand that 85.9% of the variation in price is explained by home size. Now, only 85.9%, meaning that the remainder of the percentage is made up of other factors, but square footage is still a strong predictor. For our residual plot, in both Excel and AI, the residuals are mostly scattered around 0, and that helps suggest the linear model is very reasonable. The only difference is that AI may describe the pattern in words. Again, Excel shows it visually. It just matters because if there were strong patterns or curves, it would mean the linear model was missing something. But we can see that through forecasting. This is just where we apply the regression model to predict homes based on square footage. Now, in both AI and Excel, they can generate the forecasts, but Excel is especially helpful when we want to repeat those calculations over and over again, while AI is better for the interpretation. The importance of this step is to show that regression can be used practically and not just statistically to estimate those listing prices in the real world. Recommendations: Just based on our analysis, our recommendation is to use this model as a strong starting point, but not as the only factor in pricing. Homes with unusual residuals, should be reviewed, and other variables like neighborhood, bedroom, bathrooms, or condition should be added in the future. We just find this important because square footage can explain a lot, but it will not explain everything. Finally, just in conclusion, our data set shows a strong positive relationship between home size and home price. The correlation was 0.927, the regression model fit well, and the R-squared was 0.859. Overall, both Excel and AI supported similar conclusions, and together they ended up providing accurate calculations and useful interpretation. Thank you for listening to our regression analysis for Team 3.